So my name is ANDREAS. I'm a solutions architect for AWS. I'm based out of the UK, but you probably can tell from my accent I'm not originally from there. Before joining Amazon, I was in Athens as a co-founder of a Greek startup. So it's great to be in Spain. It feels like home. And hopefully today, we're going to give you a good idea of what customers of AWS and non-customers of AWS, what kind of applications they're building based on constrained devices, so what some people call the Internet of Things. And those devices, how they can be connected to services on the AWS platform and take advantage of large-scale data analytics to create very sophisticated applications. Hopefully after the talk, you will also have a good idea of the building blocks that you can use on AWS to build those kind of applications. And since we are in Spain, let me start with an example from Santander. So a very cool application where very small devices are located under the asphalt, and they can detect whether a parking slot is used or not. And then there are these panels that help drivers go quickly to a location that has free parking slots. So a very cool application here. And last week I was in Las Vegas, where Amazon did the annual customers conference. And one of the days we did a hackathon about Internet of Things, where customers had the opportunity to use various devices and quickly connect them to AWS. And it was impressive how those customers, within 2 hours, they were able to send events from various sensors up to the cloud. And then until the end of the day, they had meaningful dashboards and sophisticated applications running. So we have a lot of data. A lot of that is machine generated. We have servers. They produce tons of log files and events. We have mobile phones. We have telematics from cars. So all those machines generate a lot of data. And it's not only that. We also have human-generated data, behavioral data from social media, but also behavior actually on a physical store. So you go to a supermarket, you use your loyalty card so that we can track what's your behavior, and we can personalize your experience and the offers that you get. And if we go through the life cycle of data, we go from the generation of data through the collection and storage, and then we have to do something meaningful with that. We have to analyze it and do some computation. But this means nothing unless we can collaborate and share upon those insights. And what we see those last years, it's very interesting because the cost of data generation is falling. So we have a lot of small devices. Some of them have constraints. Some are a bit more powerful, actually. They can even run proper software applications. And they can generate a lot of data. So this cost is going down. And actually, it's not only the devices themselves, it's also the connectivity that we have to upload those data into server-side applications. So we have higher throughput on that. And until recently, what was really the bottleneck, what was constraining us of actually doing something meaningful with this data, was that the collection and storage was highly constrained. We have a lot of customers that tell us, I can produce a lot of data, but where should I store it? I don't want to store it in my database. It's not made for that. And then if I have this data, how do I analyze it? What do I do with that data? How do I share it in an efficient way? And this is the kind of graph that we see that is predicted. Companies producing a lot of data, not being able to analyze it and make use of it. So in AWS, one of our objectives is to change that, to fix that problem. How many of you are familiar with AWS? Can I see your hands? OK. So just an introduction. You're probably familiar with Amazon, the retail. Well, AWS, Amazon Web Services, is a different division. It's a different business. It is what we call cloud computing, infrastructure as a service, IT resources that are available through an API and in a pay-as-you-go fashion. And analysts around the world consider Amazon Web Services as one of the leaders in this space. Actually, Gartner places us in the leading position last year for both the ability to execute and the completeness of vision. But what is more important for us is actually the companies, the customers that are using us. And we have many popular internet businesses. You can probably recognize a few names here on this slide that take advantage of AWS and build the whole business on top of that platform. And it's not only startups and internet companies, it's also old-fashioned enterprises that want to be agile and work as startups and disrupt instead of being disrupted. And they also move workloads on AWS. In some occasions, they even shut down complete data centers to take advantage of the agility. They don't care so much about cost as new startups do, but they care about the agility. And the AWS platform consists of 3 main pillars. You might be familiar with the compute side of things, so virtual servers that you can launch within minutes, but also the storage services and the database services. And all that is based on the foundation of a global infrastructure. We have multiple regions around the world, and you can choose to deploy your IT resources closer to your end users. And all that is surrounded by a networking layer that you can build securely and isolate different applications within your stack. On top of those pillars, we also have application services. Those application services, we're going to see some examples of those, how they can help you build more with less. We're going to see some startups have very few people, but they are able to build very sophisticated applications and stacks. And everything is available behind an API, so everything can be automated, fully automated, so that you don't have to manually do things. And we're talking about anything from a full compute cluster. You can launch hundreds of servers within minutes to databases and Hadoop clusters, etc. And there is some natural affinity between big data and the public cloud. The reason is that AWS offers elastic and scalable infrastructure. This means that you don't have practical constraints. You can launch many different servers. The ability of AWS to aggregate multiple customers on the same infrastructure gives us the ability to practically give you the capacity that you need when you need that. It also comes without any upfront investment. You don't need to guess how many resources you're going to need, how much capacity you will need, and you only pay per use. We're going to see how this facilitates new models that didn't make any financial sense before the public cloud. It's also self-service, meaning that you can launch new resources within minutes without any interaction that can take time. So no lead time. This removes the restrictions and the barriers. Removing those restrictions allow us to experiment more and produce more innovation. Hopefully what we can do is accelerate all this data cycle from generation down to the collaboration and sharing of that. And the foundation of that is storage. So we need to store a lot of data. And in AWS, the foundation is S3, Simple Storage Service. This is internet storage, object storage, where we pay only for what we use. We don't need to allocate specific capacity up front. We just upload data as and when needed. And those are durably stored across multiple data centers in a specific region. And then, if we want to store data for long periods of time, we can save money by moving those into Glacier. Glacier is the archival service of AWS. So you can see how we can combine those two services to optimize for our use. And this is an example of Illumina. It's a company producing DNA sequencing instruments. And those traditionally produce a lot of data. And biologists take advantage of this data. They analyze it. They would have to work with hard drives that they would have to move physically. So this company had the vision to stream all that data onto the public cloud and take advantage of S3 and Glacier. and then create an application so that different users can collaborate, analyze those data. So this is why they created the base space application. And of course, storage of raw data is good, but sometimes we need schema, we need databases. So on Amazon, you can launch relational databases. You can, of course, install them on your own on virtual servers and deploy whatever kind of database you want. But we also have a service for that, so that you don't have to deal with the day-to-day administrative aspects of managing a database engine. You just launch a database instance, you specify whether you want it to be a MySQL instance, Oracle, Microsoft, or Postgres. And RDS is going to deploy that for you. It's going to handle all the security patching, the backups, and the data migrations if you change the database size. And relational databases are great for some use cases, but when we are talking about big data, and when we are talking about high throughputs, high write throughputs, we know that they have some limitations. They can scale nicely for read-heavy applications, but for big data, it's interesting to have NoSQL distributed databases, databases that are designed from the ground up for this kind of workloads that we're talking about. And again, you can deploy your own on EC2. We have many customers that deploy MongoDB or Cassandra on EC2, but we also have a managed service, a fully managed service. It's called DynamoDB, and this allows you to just have a dial and say, I need so many reads and writes per second, and DynamoDB on the background is going to launch sufficient partitions to give you that capacity. Again, you don't have to deal with any hardware, with any configuration of storage, etc. And then for analytics and being able to give your data scientists a data warehouse where they can use business intelligence tools and familiar SQL language, we also have the Redshift service. This is a distributed data warehouse that can be used to mature all your data. Essentially, we're talking about petabytes of data that you can store on Redshift. And this is an example. Dropcam, it collects video streams from multiple devices around the world. And of course, they are using S3 to store the videos themselves, but they also need a lot of metadata storage. So they use DynamoDB. They moved from relational database to using DynamoDB. And essentially, the more devices that they have, the more capacity that they need with DynamoDB. And they don't need to worry about how they will scale. They just increase the dial as their usage increases. And you can see here how the move to AWS for this company facilitated a very rapid growth in terms of utilization for their service. It will be very hard to do this in traditional data centers if they had to do it on their own. Another good example for DynamoDB is Shazam. Shazam, for 1 day per year, when there is a Super Bowl event in the US, they allow their users to tag the whole event, and they need over 500,000 writes per second. So what they do is, for that particular day, they increase the throughput on DynamoDB. They only pay for that, and then after the end of that event, they scale down. A good example for Redshift is the usage at Foursquare. They reduce their cost by moving from a traditional data warehouse to Redshift, and they use Tableau, which is a very popular business intelligence tool and visualization tool, to give their internal users the ability to understand more about their users. So we have solved this problem. We can store a lot of data. That's great. But how do we go about analyzing that data? And the solution is to massively parallelize the processing of that. And the nice thing about AWS and how it is a natural fit for that kind of workload is that one server for 100 hours will cost the same as 100 servers for 1 hour. It's actually even more than that. We can bid for unused capacity on AWS, what we call opportunistic computing. and we can get the same job done for a lower price. And here's an example where Bank Inter, they need to analyze credit risk, and they need to run multiple simulations. By moving that workload into AWS, they were able to reduce the time from 23 hours to 20 minutes, just because they could run more jobs in parallel. And here you can see the kind of workloads that we are talking about. For them, it's really important to produce those results quickly, for example, when the stock market closes. So you can see those peaks and valleys. Normally, they would have to procure as much capacity as required for those peaks, and the rest of the time, it would be idle. Before, they couldn't justify having all this capacity procured just for those peaks. So this is a great example of how the seasonality or the peaks within a day can be accommodated on the public cloud. So everything that was a constraint before, the number of servers, doesn't have to be anymore. We shouldn't treat it as a server or as a box. It's now just a programmable resource. We can launch servers to perform a task as if they were software variables, if you like. And I'm sure you all know Hadoop. I don't need to introduce Hadoop in this audience. And it's a great framework for dividing and conquering your data analytics. But building and maintaining a Hadoop cluster, it's kind of hard, especially working on scale, on high scale. And even if you have those skills internally and you don't find it hard, it's something that doesn't change between one company or another. It doesn't matter if you're a bank or if you're an e-commerce or a startup. Running a Hadoop cluster itself and operating that is not fundamentally different. And on AWS, we like this kind of problems. We like to find those problems that are similar across different customers, the undifferentiated heavy lifting, as we call it, and providing them as a service. Essentially, we want to allow you to focus more on your business, on the algorithmic side, on the data science, instead of the infrastructure management. This will allow you to spend more on your business and on the core of what you're doing and how you differentiate from competitors, for example. An example of that is Amazon Elastic MapReduce. This is the managed Hadoop service. It allows you, with a few clicks or programmably through the APIs, to launch a cluster of Hadoop, and that can be an ephemeral cluster that you only use for one particular task and then you shut it down, or it can be a long-running cluster. And Elastic MapReduce integrates nicely with services like S3 and DynamoDB that we described before, so that you can seamlessly analyze the data that you are storing. It also integrates with the whole Hadoop ecosystem, things like Hive and Pig. And some of our customers can be confused, and you might have the question here, should I use Elastic MapReduce? Should I use Redshift? What kind of database should I use? And there's no clear answer to that. The answer is you can combine those to build sophisticated workflows for your data. We have customers that store their raw data on S3, and then they use MapReduce to deduplicate or to transform this data. They can aggregate it and store the result perhaps on a relational database so that the end users on the front end can query that. Or they can create meaningful dashboards stored on DynamoDB. And at the end, you can move all your data into Redshift to store it there so that the data can mature there for long term. And we have a service called AWS Data Pipeline, which can facilitate all this movement of data between the different services. So that's great, but we're talking about data that is essentially processed a bit offline in batches. So we collect data in increments, and then we send it perhaps to a MapReduce job to analyze it. This is good in many use cases, but we see more and more scenarios where this is not enough. It's not enough to have big data. We also want fast data. And we have mobile phones that are not only the user interface, but also the collection point for our data. And some very interesting scenarios for commuters. So we see the One Bus Away application for New York and Atlanta, where they have GPS devices installed on buses so that commuters can see exactly where those buses are and how long they're going to have to wait for the next bus. And then Moveit is an Israeli startup that is built on top of AWS. And what they do is very interesting. They collect data from various sources, also from end users, giving them the ability to give a very clear picture, almost real-time picture of what is happening in the city and what's the fastest way to get from one point to another. So we want to process things very quickly. It's important what is happening now. If we wait 2 minutes, 3 minutes, 4 minutes, it's too late. So we want to process analytics in a stream in a near real-time fashion. So we have a service for that. It was introduced last year. It's called Kinesis. It comes from the Greek word, and it means movement, activity in response to a certain stimulus. And this is a great name for this service because what we have is a lot of data sources on the left, and they all feed data into Kinesis. Kinesis stores those in a durable way in multiple data centers in a specific region of AWS. We call them availability zones, so that you have very good confidence that the data is there. It will store those, and it will stream those to applications on the right. Multiple applications can consume the same stream of data. And those data are moved with the same order that they are received. And you can see an example here where you have one application doing the duplication of data, perhaps storing it on S3 as a result. Or you might be extracting specific metrics, creating alarms, or storing those in a dashboard on DynamoDB so that you can see what is happening now, what are the top URLs that are visited in a particular website, for example. Or you can kind of simulate MapReduce, but for real-time data, by using sliding windows and doing analytics on those. Or you could use things like machine learning. You can still use MapReduce on top of events that come through Kinesis. And the way that Kinesis can scale is by simply adding more shards. Each shard can ingest up to 1 megabyte per second. And all the data are stored for 24 hours. This means that we are decoupling the ingest of the data with the actual processing. If there is an issue on the back end, well, we can replay the stream a bit later. And you can add shards and remove shards during the same day. And this will give you the ability to adjust to your real capacity requirements and only pay for those. And the way that we put data into Kinesis is very simple. We have put commands through the APIs, and we need to select a certain partition key. A partition key is what allows Kinesis to split the data into multiple shards so that we can scale without any practical limit. We just keep on adding more shards. And then we get a unique sequence, which is what I mentioned before, that we maintain the order in which those events are recorded. And you can use an application that will collect data and store it on Kinesis. This is interesting when you have devices that are very constrained. They cannot use, for example, HTTPS to connect to Kinesis on their own. But in other cases, like the example here, you can have, for example, a Raspberry Pi running Python. This can run the command line tools of Amazon or a software written with the SDKs. And those can stream directly into Kinesis if they're given the right temporary credentials. In this example, we have an analog sound sensor that streams information about some kind of sounds, perhaps the noise level, etc. And then how do we consume the data out of Kinesis? So we can write multiple applications that will stream the data in the order that was received. And you can do that on your own from scratch, but we have libraries written in Java and Python that can help you write those applications faster. Because there are still some details that you need to handle on your own. If you use those libraries, you don't have to deal with those. Things like, how do I make sure that I have one processor per shard? Or what happens when I add more shards? I need to add more processors on the other side. So those libraries are going to take care of that and reduce the overhead for you when you design your applications. So this is how it looks end to end. We have the devices that produce data that are streamed into Kinesis, and then they are processed by applications written and deployed on EC2, which are the virtual servers of AWS. And in some cases, we just want to do a very simple processing. We just want to filter data, and we want to then perhaps store it on S3, DynamoDB, Redshift, or Elasticsearch to do perhaps some analytics then with Kibana and those kind of tools. So we have some connectors that are already built that you can use straight away. You can deploy them very easily on EC2. And you can take those examples and design your own if you want to connect to a different storage system. This is an example where we have Kinesis recording advertisement data in real time. And we have multiple applications. We have one application that is perhaps incrementally performing analytics on those, storing them on S3, aggregating those. Another one could be just storing the raw data if we want to run further analysis in the future, again on S3. Those could then be moved into Redshift for our internal users to run SQL queries on those. And we could also have one other application that will create real-time alerts on billing, perhaps, or produce a dashboard. So the benefits of Kinesis is, first of all, easy administration. You don't have to launch such a solution on your own on EC2. It gives you near real-time performance. When we're talking about real-time performance, we're talking about a few seconds. It is high throughput and elastic. You can just add more and more shards. There is no practical limitation. And then we have integration into S3, Redshift, and all those services that we talked about. So it's not just a single service, it's the whole ecosystem around it. And it's also low cost. You can start very small with a single shard if you have a small application, and you can just add more nodes as required. So this is how it all looks like. This is the whole big data portfolio on AWS. Many services. We have a whole team locally here in Spain that can work with you. They're here, so at the break you can find me and the team. We're going to be outside. We can talk about your use case, and we can try to understand what you're trying to achieve and how to combine all those services together. And I just want to introduce a new service that was launched a few days ago. So it's great that we have Kinesis and we can use relational databases and data warehouses. Some of our customers told us that they don't even want to deal with virtual servers. It's great that we abstract that, but it would be nice if they could just give us code that would react to specific events, for example, when a file is uploaded or when an entry in the database is made. And then this is the service that does exactly that, so it's called Lambda. You provide Lambda functions written in Node.js. You don't have to deploy them in any kind of server. You just register them to specific events, and those events can be different events that happen on the AWS side, or you can invoke them through the APIs. And then Lambda is going to execute those on the events that you registered with that. Again, no servers to manage. You just upload your code, and it just works. So with that, I'm going to open for questions if we still have time. OK, great. Yeah.
Would you recommend to use S3 instead of HDFS? And if so, is S3 scaling as good as HDFS is scaling?
OK, so the question is around whether we should use S3 or HDFS, and whether S3 scales as well as HDFS. So there's no clear answer to that. The idea is that you can use S3 to store your data persistently. It will scale much more effortlessly than HDFS. And in different scenarios, we recommend that you actually copy the data into HDFS. If it's long-running jobs that will stay there, you don't want the overhead of copying the data from S3 into HDFS every time. But in some other cases, it's beneficial to have files in S3. It depends how long it takes to copy the data into HDFS. But there's very easy integration between EMR and S3, so that you don't really have to deal with the overhead of copying the data around, because EMR takes care of this complexity for you. And in terms of scalability, S3 is going to scale as much as needed. It will repartition itself as you add more data, as you increase the throughput in terms of reads and writes. It's something that you don't need to worry about. It's also designed to be spread across multiple data centers so that you have the durability for your data.
Questions, maybe we can have also the light of the room, so we can spot raise hands.
If somebody also doesn't want to ask a question in public because it's a particular use case, we can talk about it later on.
Yeah, that's right. There's a whole team of Amazon Web Services here. OK, thank you very much, Andreas.
Thank you.
Very nice.